Hello guys, today's lead code problem is insert, delete, get random of big O of 1. Okay, and it's a creative problem and it's a medium problem here. And as this is an easy problem here, uh, just we have to take care of one thing here, just the get random function we have to take care of. That's it, and we have to take care of this thing also. Like we will eventually see this how to take care of these functions. Okay, like we'll first try to understand the problem here, like implement the randomizers set class. Okay, there is a randomizer set class. We have to implement their functions. Okay, functions of the class. Okay, there is a function called randomizer set which initializes the randomizer set object. Okay, this is a constructor type here. This is a constructor of randomizer set class. Okay, and there is a function called a bool insert, and it also takes an argument called val. Okay, we have to insert an item val into the set if not present. Okay, returns to if the item was not present, false otherwise. Okay, bool and another function remove, we have to remove an item val from the set if it is present, return true if the item was present, or else false otherwise. Okay, and another function get random. Okay, we have to get a random element from this current set of elements. It's guaranteed that, and there is a note called, it's a guaranteed that at least one element exists when this method is called. Okay, whenever this method is called, we can expect that at least one element will be in set. Okay, each element have the same probability of being removed. Okay, so you must implement the functions of the class such that each function works in average big of one time complexity. Okay, first uh, we will see a brute force approach here. Afterwards, how we will implement that brute force approach into big of an average time complexity. Okay, first we will see brute force approach. Okay, so first of all, what we have to do here, uh, in hash map or hash set, the time complexity for inserting or removing or checking whether it is present or not takes an average of big of one time complexity here. Okay, we have to take note of this in hash map or hash set. Hash set is indirectly implemented by hash map only. So for mm, inserting, removing, or for checking its existence, Tense existence in the set or map takes average TC of big of one only here. Okay, for inserting, removing, or checking whether it is present or not takes an average time complexity of big of one only. So we can use this hash set to get the what get the to implement these functions, right? So first of all, we need to declare the hash set here. So we will use set here for it. Okay, to implement these functions. So set, we will now in the constructor, whenever the constructor is called, we will initialize this set. Okay, okay, and coming to this function, we have to check whether it is present or not, right? According to that insert function, insert an item val into the set if not present. Okay, first we need to check whether it is present or not. If set dot contains val, if it contains val, then we don't need to do any further operations, right? It is already present. It is already present, so we should not include it, right? We should not insert it again, right? So we will return false here. Okay, or else we need to add val here, and we need to return true. Okay, and for remove function here, first we need to check whether there is a val in the set or not. Okay, contains val, then we can happily remove that element from set, right? So set dot remove val. Okay, and we need to return true here, or else we need to return false. If it is not present in the set, then we can return false, right? And here for random element from uh, getting random element uh, from set is I will use a function called random here. Okay, I will use a random class here to get the random function here. Okay, random. Okay, this function, what this class do is, this class has a function called has next. Okay, has next. uh, I think I will just random function on set in Java. Okay, so if you do here, see, it has a next int. Okay, it has a function called next int dot next int, which takes a parameter as size here. Okay, so for getting, okay, we'll search it in this thing. Now see, uh, here random dot next int hash dot size. Okay, so this function has next int which returns the index of that value. Okay, randomly it selects an index and it will return that index. Okay, so it will return index here. With this index we need to iterate over the set and we need to get that index value. Okay, so r dot next int, and we have to provide here set size, right? We will provide set dot size here. Okay, now for now we will initialize I equal to 0, and for int le belong to set. Okay, uh, if I equal to idx, then we can directly return it, right? So return le, or else we need to increase the I plus plus, right? So in this way we can uh, return the, or else we can return -1 here. This case doesn't happen here because in this case only it will so it is already said that there is an at least one element present in the set. So this line number 31 never exists, right? Okay, never comes to. So the function has to return something, so I have written here return -1. Okay, so in this way we can solve this problem in a brute force way. So coming to the time complexity of the problem. Okay, this takes an average of big of one time complexity. Okay, for inserting an element, and for removing an element, average time complexity of set is big of one only. So this takes an average time complexity of big of one, because for getting an element it takes big of one, for but accessing element from set it takes big of n, right? It has to go to every element of set and check for its index and all, right? So because set doesn't have index based values, right? So it has values in a random order. So to achieve this, we will be storing this. Uh, we'll be storing these all set elements in a list. Okay. So with when it is stored in a list, then it is easy to access elements, right? In big of one only we can access elements, right? By if we know the index of particular element, then we can easily access that element from list, right? So this is the optimal way here we have to think of, okay, by storing the elements in a list, okay. So how to store the elements in a list, okay. So first of all, we need to now these we are done with brute force approach, right? Now we will think of a optimal approach, okay. So so it's, uh, in so for optimal approach we need to make this grid random function uh, time complexity to big of n to big of 1, okay. So we our main goal of optimal approach is to make the time complexity of grid random function to big of 1 time complexity, okay. How to achieve this, okay? The big question is how to achieve this, okay. Now, okay, now for example, uh, we take list here and hash map, okay. Hash map has a property called integer comma integer, right? Here key will be the value which the function is having, and mm, the value will be and the value will be uh, the index of the value which it is present in the list, okay. So the index of the value at the list, okay, will be the value of the map, okay, key value, right? So here in hash map, key will be val, okay, and value will be index of val in list, okay. This is the hash map we need to create, okay. And list is for storing the values, right? Okay, values, these are the values, right? For storing these values, okay. So we will be implementing this type of functionality here, okay. Okay, now we need, what else we need? List integer and the list equal to, okay, first we need to create this, right? Hash map, both are of integer type only, right? Key value so hash here. Now whenever the constructor is called, list equal to new array list, right? And hash equal to new hash map, okay. So now what we will do, we will be inserting, so whenever the insert function is called, we will be checking for checking, okay. We have to check, right, whether it is present in hash map or not, right? So we will check it if hash dot contains key. If it contains key, no need to add it again, right? So in this case we need to return false here. If it not present, then we need to add, right? Before adding it, now we will, before adding it, first we need to add it to the list, okay. So what will be the index of this value in the list here? It will be list dot size minus one, right? Before, because it will be added in the last of list, right? So okay, so the index of the val will be list dot size minus one, okay. Now we will put that in map only, okay. Val comma list dot size minus one, okay, and we will return true here, okay. Now coming to the remove function here. Now here this is the main function here. Now we have to check many cases here, okay. So so whenever we are removing something, we have to again, so why we are storing here key value, like value comma index, because to remove that index value, okay, to get access, to get easy access here, to get easy access over list, okay. To get easy access over list, we need to, we are storing in a hash map. Okay, index also we are storing it in a hash map, value comma index, so that we can get the easy access to list. Okay, or else if it is not present, we need to go to list again, and we have to iterate over it, and it takes big of n, right? With by using hash map, we can get easily in big of one only we can access that list elements. Okay, so now before going through this function, first we need to check whether it is present or not. Hash dot contains key. Okay, okay, if it contains key, then it is available in the map and we can remove it, right? So if it does not contains, like if it not contains key, so there is no value in the hash map, so we cannot remove any value which is not present, right? So in that case, we need to return false here. Okay, and now now we will access the index of the value here. Okay, hash dot get val. Okay, now we got the index of value, and we need to go to set, go to list, and we need to remove that element from list. Okay, so before removing that list, we need to do one thing here, because we need to do one thing here. What is this? Because, so for example, if the elements are in this way, if we want to remove 3 here, which is at index 1. Okay, so we need to remove 3 here. Okay, so uh, for removing 3, what is the, okay, one second, let me think of a test case here. And so if we know the index, we can directly remove it from that index, right? And to map it to a new index, we need to, okay, okay, so when we, so now uh, let us see example. Okay, now this is a test case, right? And map also we will see. Okay, one map to 0 index, right? And two map to 1 index, right? And 3 map to 2 index, right? And 4 map to 3 index, right? And 5 map to 4 index. Okay, now we have to remove that element from that list, right? So if we remove this element, now observe here, the indexes of 4 and 5 are changed here. Now it will become 2 and 4. So 2 and 3 here. Now we have to go to them again, go to the indexes again, and we have to uh, change the indexes of 3, 4, and 5 here. So it will again take big of n operations, right? So we have to go again, we have to iterate over hash map, and we need to change the indexes, right? So if we remove an element from a list, we directly, so it is like how we can say, uh, mm, so it is it takes big of an operation to set all the indexes of other elements also in a hash map, right? So before removing this element from list, it is, now we will do one thing here. Okay, now it is a 3, right? So now we have to remove 3 from list, right? So before removing a 3, we will set the 3 to last element. Okay, set the 3 to last element, and we will update that last element value, last element value index in hash map to the parent present index. Okay, and we will remove this index. So now the 3 is removed, and the indexes of everything is, the indexes are also recovered, right? So observe one thing, and I will explain it again. So if we want to remove 3 here, so okay, we will set, first of all we will set the 3 to 5, okay, 3 to 5 in list, and we will update this fifth element index to 3 2, because it will be idx only, right? So we will update this index, and we will remove this from hash map, okay, and remove 3 from hash map, and also remove last element also from hash map, because it is already present in second index, right? In this way we can handle all the edge cases right here. In removing function we can handle edge cases, and this overall time complexity will be big of 1 only, right? So in this way we can achieve big of 1 functionality by doing this thing, okay. So uh, we'll just implement the remove function now, okay. Now what we have to do, we have to set, okay, list dot set indx comma list dot get. We have to set it that the index value to newer element, right? List dot get size -1, okay. Why only last element? Because why not the side element +1 or -1? Because see, if there is only one element present in, if there is only one element present in list, okay, and we have to remove that element, okay. So when we try to access the +1 element, then we will be getting the index out of bound condition, right? Or else if we try to access the -1 element, like -1 index, like -1 index element, then it will also get index out of bound exception, right? To avoid this index out of bound exception, so we are setting the present index element to the last element index, okay. So after setting that, we need to remove it from hash map, okay. Hash dot remove, what is that index, what is that value, val, okay. Hash dot remove val, and also we need to modify the hash dot put um, uh, list dot get indx comma indx, right? In this way we can do this operation in big of 1 time complexity, okay. We have taken the index of that element in from hash map, okay, and we have set the index element to the last element of list, and we have removed it from list, and we also need to remove it from list dot remove list dot size -1, and we need to also remove last element, right? Because it is already present in the idx, right? We need to remove it from this thing, okay, and return true here, true from here, okay. So I think we have handled this the every edge case from here, right? So now coming to the random function here, random function will be more easier here. Now first we need to create a random class here, new random, okay, and create, after creating, we can directly return list dot get r dot next int comma and list dot size, okay. In this way we can directly return the random element from here. Earlier we were taking big of n operation for this, right? But in this case we will be taking only big of 1 operation, because accessing element in list is big of 1 only, right? So here up uh, this thing will return the index of the element which is randomly selected, and this will get the element from that index. Okay, so we will try to run this. Okay, okay, it is accepted. Now we will try to submit it. Okay, it is getting false, false, true, 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 false. Okay, now we will try to visualize this test case here. Okay, and first the randomizer set will be called. Okay, and other and remove function will be called. So in this case, there are no elements to remove, so it will return false here. And again, remove function will call. In this case also, it will there is no element present, so it will return false. And insert zero. So our hash map will have zero here, and it will be at zero index only. Okay, get random, and so here we will return zero here from. Okay, only because only one element is present in our set, so we need to remove it from. So we will remove here. Now there will be no element in set, and we need to insert. So here, uh, so it should return false. It should return true, right? So hash dot contains key. Well, if it does not contains, then we need to return false. Okay, this is correct, right? And we need to insert, right? Insert zero. Okay, list dot add val. Okay, and return true. This should return true, right? Why it is returning false here from me? And get random function, and zero will be removed from here. Okay, after removing zero, what is the okay? What is happening here? Okay, let's just check the remove function here, and it will get the value, and it will be return zero, and list dot set index to list dot get list dot. So same value will be set. Okay, and okay before um, hash dot remove value. Okay, we need to remove it from hash map, and we need to put that list dot get. Okay, okay, okay. I think here we are doing something wrong here. Mm, hash dot put a list dot get index. Okay, index and comma index. Okay, we are mapping with that. And mhm. Why it is getting true here? It should not get right. False, false, true, zero, true, false. It should be true, right? Why am I getting this then? What am I doing wrong here? If hash dot contains key, it is already present, so we need to return false here. Okay. List dot add val. Mm-hmm. Okay, I need to do this thing. After this thing, I guess. So if I run this, yep. Now when I try to submit it, okay, now it is accepted because see, observe here one thing. Uh, Wrong answer, right? So here we need to remove that element, right? After performing the whole operation, we need to remove that element, right? What were we doing? Because what were we doing is we are removing that element and we are performing this operation. So this is not correct, right? So first of all, whatever the operation we are performing, we need to do that, and after that, we need to remove that element from a hash map, right? So in this way, uh, this was the thing happening here. So we rectified that and we solve this problem in big of one approach. Look, coming to the time complexity here, this overall time complexity is big of one only for insert function, and for remove function is also big of one only, and for random function also it is a big of one operation. So in this way we can solve this problem, and it is two type. And when we have solved it in brute force approach, where randomized get random function was big of an operation, and the optimal was making the random function to big of an operation. So we have successfully made it. So this is the solution, and thank you.